Okay, so this review is all about u substitution. Now that does not mean every question needs u substitution, but it's a possibility. If I look at this first example, I've got t to the fourth, and then I've got the cubed root of all of that stuff. And what you're looking at, this would require product rule and chain rule, so that's a hint that you're going to probably need a u substitution. Looking at this, I'm going to let u equal 3 minus 5t to the fifth. That's everything that's underneath the radical. So if I had rewritten that as 3 minus 5t to the fifth, that would be raised to the 1/3 power. So whatever is getting raised to the power, you want to try that. I'm also thinking ahead, and if I take the derivative, I've got negative 25t to the fourth dt. So this is the key. The negative 25 I can compensate for by putting a negative 1/25 out in front. For my integral, this only works if I can find that t to the fourth dt, which is right here and here. So what happens is, the t to the fourth dt, when I write down du covers, so I've got negative 25, so that's what I have out in front. T to the fourth dt, that stuff is now being written as du. So what I'm left with is the cubed root of u. Okay, so now when we take the antiderivative, negative 1/25 times, this is really u to the 1/3. So if I add 1, I get u to the 4/3. Instead of dividing, I'm going to multiply by the reciprocal. And then, of course, I have plus c. And then you want to make sure you rewrite it because you have to bring it back to u's. I can do this as negative 3 over 100, and then 3 minus 5t to the fifth to the 4/3 plus c. Just some basic simplifying there, okay? On the answers that I gave you in class, that one's actually incorrect because I wrote it as a square root, not a cubed root. So either take the cubed root out and follow the answers that I gave you, or if you have the cubed root in there, this is the correct answer. Now, for number 2, if I look at this, if I wanted to make u equal 1 plus x to the third, then du would be 3x squared dx. I don't have an x squared. I know the 3 I can compensate with a 1/3 out in front. I do not have an x squared anywhere in this problem, therefore this doesn't work. You cannot get an x squared in there. So what you have to do is you're going to have to distribute, and this integral becomes x plus x to the fourth dx. Now it's a nice easy integral. X squared over 2 plus x to the fifth over 5 plus c, and you're done. Okay? Now, looking here at question 3, I notice I have a 2x times sine of x squared. I would need product rule because I have a 2x and a sine. I would also need chain rule because I have sine of x squared. So what I want to think about is, what do I want u to equal? And again, in my head I'm thinking, if u is sine of x squared, then du would be cosine of x squared times 2x. I don't have a cosine in here, so I can't do that. What if I let u equal x squared? Then du would be 2x dx. And that's exactly what I have. I don't need a reciprocal out in front because I have that 2 there. So when I rewrite this, it's the integral of sine u du. I integrate, I get negative cosine u plus c, and then I just sub back in. And there you go. If I look at the fourth question, I've got cosine cubed x sine x. So what I want to look at is the overriding fact is that I have something getting raised to the 3rd power. So that's what I want to look at to let u equal. So if u is cosine x, then du, the derivative, is negative sine x dx. The negative 1 I can compensate with the reciprocal out in front. Integral, that sine x dx, that now turns into du. That right there, all of that is my du. And instead of cosine cubed, I now have u cubed. Integrate, negative 1 times u to the fourth over 4 plus c. So this is going to be negative, and then I've got cosine x to the 4th all over 4 plus c. Okay? So now, number 5. If I look at this, I've got a square root. Well, let me look at what's under the square root. If I take that, if I let u equal sine of pi theta, then du is going to be cosine of pi theta, chain rule, times pi d theta. So now, that pi, it's just a constant. So I can take care of that by putting the reciprocal out in front. Cosine of pi theta d theta, that's all right there. That turns into my du, and this becomes, instead of the square root of sine of pi theta, it's going to become the square root of u. So the integral becomes the square root of u du, and then I integrate 1 over pi times, that's u to the 1/2, add 1 to your exponent, and then divide by that or multiply by the reciprocal, plus c, and your final answer, if I just rewrite this as 2 over 3 pi, and then I have sine of pi theta raised to the 3/2 plus c. Hopefully that's helping you out a little bit there, okay? On the back, if we look at this, number 6, I've got a whole bunch of stuff raised to a power. So once again, what if I let u equal that stuff? Then du would be 2x dx. Do I have a spare x in this problem? No. So I can't do that. What I need to do is I need to rewrite this as the integral of x squared minus 6, x squared minus 6. You need to FOIL that out and then combine like terms and then take the antiderivative. Question 7, what you want to ask yourself, is it cosine of x or cosine of something other than just an x? It's something else. So you want to use a u sub. Let u equal that stuff. Then du is, it's just 1/3 dx. Remember, x over 3 is the same thing as 1/3 times x. 1/3 is just a coefficient. The derivative is just 1/3. Now, I need the reciprocal out in front, so I end up having a 3 out in front, cosine u du. Now you can integrate and then sub back in. Looking at number 8, if I look at this, 6 is a constant, so I can just pull that out in front if I want to. I can just stick a 6 out in front of my integral. Now I have 1 minus 2x getting raised to the 3rd power. Even if you rewrite this as 1 minus 2x raised to the negative 3, it would still require a chain rule. So no matter what, you want to look for a u sub. If I let u equal 1 minus 2x, then du is negative 2 dx. So when I do this, I already have a 6 out in front because I brought my constant out in front. Now I need to multiply by a negative 1/2 because that's taking care of the negative 2. The integral becomes either 1 over u to the 3rd or just u to the negative 3 du. So this then turns into, in front I have negative 3, and then I have times u to the negative 2 over negative 2 plus c. Looking at this right here, a negative times a negative, that's going to be positive. My 3 stays on top. In my denominator, I've got this 2 right here. And then this negative exponent is going to move everything down. 1 minus 2x squared plus c. Number 9, look under your radical. I'm used to a radical x, that I can do. But the square root of all that stuff, I want that stuff to equal u. So you can try that one. You have the answers. Number 10. Looking at number 10. First of all, this 3 right here, it's just a constant. I can move that out in front. However, it's not a 3 that goes out in front. That's a 1/3 that moves out in front. Now I don't even have to look at it, okay? Now, I have sine of 1 over x, and then I have an x squared in my denominator. If I let u equal that x squared in my denominator, then du would be 2x. I don't have an extra x in my problem, so that's not going to work. Now, if I let u equal 1 over x, if you recall, that's x to the negative 1. Then the derivative is negative 1x to the negative 2, which is just negative 1 over x squared dx. Now what you need to do is, do you have a spare x squared in a denominator? Yes, you do. So this x squared in the denominator and the dx, all of that turns into my du. So when I rewrite this, I have a negative 1. I need to compensate with the negative 1 out in front, times 1/3 is the constant that I pulled out in front. Integral sine u du. Remember, the whole point of a u substitution is to really simplify the integral. So this is negative 1/3. The integral of sine is negative cosine. So this becomes 1/3 cosine of 1 over x plus c. And you're done. I hope that helped.